Naming regular ionic compounds. So on the first day of learning nomenclature, we learned about naming just regular ionic compounds. And those compounds are ones that have a charge that doesn't change. So anything in group 1 is always a +1. Anything in group 2 is always a +2. Then over here we have NP and AS that are always -3. OS, SE, and TE are always -2. Then everything under F is always a -1. We will not be writing ionic compounds with the noble gases, and I generally don't give you carbon, Si, or B for writing ionic compounds. So for writing regulars, it will be between Li and Fr, Be to Ra, those ones, and those ones. A little messy there. And there are some here in the transition metals and outside the transition metals that have one charge only, and that charge doesn't change. Al is always a +3, so is Ga, so is In. Zinc is always a +2, and silver is always a +1. So if it has just one charge written on there, it is not a variable charge. It's a regular charge, and you don't need a Roman numeral. So if I were to give you KCl and ask you to name that, you would look up K, and there's K, and you write out the first full name. Potassium. So the first element in an ionic compound is always written out as it is on the periodic table, potassium. And now we look at Cl. Cl is over here. It's chlorine, but when it's in a compound, you change the name ending, the suffix ending, to "ide," such that you have potassium chloride. Potassium chlorine sounds weird because it is weird. So let's look at another one, LIBr. I might ask you on a midterm exam what type of compound this is. Well, it's an ionic compound because the first element written there is a metal. Well, how do I know it's a metal? Well, metals are over here in this area. These are metals. It says right there, metals. The next element is a nonmetal. Where are the nonmetals? In general, the nonmetals are over here. So anytime you have a metal and a nonmetal, you have an ionic compound. The metal is always written first. The nonmetal is always written second. And if you were to write it as ions, lithium is a 1+. Look here, friends. There's a 1+. Bromine is, woo, that's a big R, is a 1-. Over here, up to the top is a 1-. So in an ionic compound, the metal is written first. Metals are cations. And the second one is an anion, and that's a nonmetal. So nonmetals gain electrons, and metals lose electrons. In fact, metals lose their electrons to the nonmetals. So if we were to write out the name for this one, we look up lithium, or Li, and it's lithium. And then we look up Br. Where's my Br? There's Br. And it's bro. Don't forget to change the ending to ide. Now we're going to name, we'll take the name and then go to the formula. So if I were to give you cesium fluoride, there's my dot, you would need to write that as a formula. So you look up cesium. There is cesium. Cesium is Cs. And perhaps in your head you think, what is the charge on cesium? So find cesium, go up to the top, it's a 1+. Write a 1+. And now we look up F, which is fluorine. And there is fluorine. Up at the top, it's a 1-. And now excuse me, that's really a 1-. And we look at the charges. We have a 1+ and a 1-. In this game of writing formulas, we want the final formula to be neutral, and neutral means 0. So we look, does a 1+ and a 1- cancel to be 0? Yes, they do. So you just need one of this one and one of that one. And so the final formula is CSF, big C, little s, big F. And you could write a 1 and a 1 there, although that's not proper notation. So generally it's just CSF. Let's look at lithium sulfide. With lithium again, lithium. Find it on there, it's a 1+. Find sulfur, it's a 2-. 1+ and a 2- don't cancel each other out. you need two Li's to cancel out 2 minus, and the way you write two Li's is Li2S. I use a different method. I see that that's a 2 and that's a 1, so I need to crisscross, so that I cross the 2 over to there, and that one's a 1, so I cross that 1 over to there, such that I have Li2S1. So in general, I just do a crisscross method. That doesn't work all the time, but it works most of the time. Let's try rubidium oxide. Rb, we'll find Rb, there's Rb, it's a 1 plus. We will find oxide is oxygen, and it's a 2 minus. We need 2 of those for 1 of those. So I write Rb subscript 2O, and we never have charges in our final answer anywhere around here. Just the letters and numbers of subscripts to tell us how many we have of those. Let's try calcium oxide. Calcium is Ca, oxide is an O, and calcium has a 2 plus, O has a 2 minus. A 2 plus cancels a 2 minus, so we need just one of each of those, CaO. If you had crossed the 2 to there and the 2 to there, you would have had Ca2O2, which doesn't look quite right. The 2 and the 2 actually cancel to be a 1 and a 1. And that is what the final answer looks like. We don't generally write the 1 and the 1. Let's try one more regular ionic. How about barium? That's what you do with deceased chemistry teachers. Phosphide. It's always better when you sing it. So barium, Ba, Ba with a 2 plus. Phosphide is P with a 3 minus. When I look at barium phosphide, I see a 2 and a 3, and in my head magically pops the number 6. And I go, aha, 3 probably needs to go down there, and that 2 needs to go down there, such that we have Ba3, P2, and that would be neutral. I hope you enjoyed naming regular ionics. Please move on to naming variable ionics in the next one.